An epidemiologic measure that is frequently used in clinical trials is the number needed to treat. The number needed to treat can be thought of as the number of patients that need to be treated in order for one of them to benefit. So it's easy to understand clinically because, for example, if someone reports that 20 patients need to be treated to avoid one additional death over a 5-year period, that can be easily understood by both doctors and patients. This measure is used for both clinical and public health studies. For example, you might want to consider the number needed to vaccinate or to screen to prevent one additional adverse outcome. And the calculations are the same. So let's review some of the formulas. The absolute risk, or simply the risk, is the number of events in either the treated or control groups divided by the number of people in that group. So if you want to know the risk in the unexposed, it would be the number of events in the control group divided by the total number of people in that group. The number of individuals with the event divided by the number of people in that treatment group would be the risk of the exposed among the exposed. And the absolute risk reduction is simply the difference between the two. Here we look at in the absolute risk reduction, we have the unexposed minus the exposed. In the risk difference, we just simply have the exposed minus the unexposed. In the case of a drug, the exposed would be the group that received the drug, and the unexposed would be the group that received the placebo. The number needed to treat is the number of people who need to receive the intervention in order to achieve the required outcome in one of them. So this is a very useful measure. We can calculate the number needed to treat simply by taking the reciprocal of the absolute risk reduction, or could be 1 divided by minus the risk difference. So we can calculate the risk difference first, and then we calculate the number needed to treat. So here's an example. In this example, we have group A, which received the medication, and group D, that was untreated or received a placebo. The risk in group A is 4, which are these 4 dark areas here. So these individuals developed the disease and were among the 16 who received the pill. In group B, the risk is 50% because 50% of the individual developed the outcome. This group here in dark. So the risk reduction is 0.5 minus 0.25, which is 0.25. The number needed to treat is simply the inverse of that, which is 4. So we can conclude that we need to treat 4 people to avoid one outcome. And this can be seen easily because if we now, for example, focus on just this column here, we have 4 individuals who were treated and 1 developed the outcome. In group B, those who received the placebo or no treatment, we have 4 individuals and 2 developed the outcome. So if we treat all 4 of them, 1 would not develop the disease. And that is what the number needed to treat is. Risk ratio is also reported, and that's preferable to reporting the odds ratio because this one is a longitudinal study. And so risk ratio or risk difference would be the preferred measures to report. The risk ratio, for the risk ratio, we'll simply divide the risk among the exposed by the risk in the unexposed. The relative risk reduction then is calculated as we calculate how much of the risk is reduced in the treatment group compared to the control or unexposed group. And that is 1 minus the relative risk.